Welcome, folks. So in this pre-work, we're going to continue our work with exponential expressions and our properties of exponents. And we're going to narrow in on a couple of problems that you're going to have to do in calculus. I want to make it clear we're not doing calculus right now, but we're doing some of the type of exponential work that is prerequisite for it and you'll do in the middle of sort of longer calculus problems. So I will remind you, if you're rusty on your properties of exponents, or your nth roots, or your rational exponents, please look at those pre-works first, because this does build, and I think this one gets a little bit challenging. So feel free to jump back to those if you feel like you're rusty, or if you haven't had a chance to look at those first. So I want to look at this expression here, or this question here, where I've given you a function named y sub t. And I want you to rewrite it so that it only contains a sum of exponential terms. Specifically, I want you to write it so there are no radicals and no quotients in here. So what I'd like to do is let's just take that original expression, y sub t is equal to t squared divided by the fifth root of t cubed minus t minus the seventh root of t, with that fraction, that numerator, being divided by t. So we can see that we have many problems here. We've got a fifth root here, we've got a seventh root here, we've got a quotient here, we've got a quotient here, and I'm asking you to get rid of those. So first thing we'll do, and there's there's many ways to thread the needle here. There are many appropriate properties that might help us get our task accomplished. So I'm not saying that you have to do these next steps the same way, but what I'd like to do is let's go ahead and first of all rewrite our radicals as rational exponents. So I'll rewrite that as t to the 3/5. Now be very careful here, folks. Remember that for a rational exponent, the denominator is the index of our root. So I rewrote that as 3/5, not 5/3, when I rewrote that radical expression as a rational exponent. Likewise, over here, I'll write this as minus t to the 1/7 divided by t. Now again, there's many other correct moves, many other legal moves I could have done at this point. So I'm not saying you have to do this sequence of steps. What I'd like to do now is I'm going to go ahead and rewrite this t to the 3/5 in the denominator as t to the minus 3/5 in the numerator. Then what I'm going to do is let's keep this minus sign right here, and what I'd like to do is I'd like to divide this denominator into each term in the numerator. So that would give me t divided by t minus t to the 1/7 divided by t. Careful there, that's a 7. I'll rewrite that. And if I continue, we've got t to the, I'm going to go ahead and rewrite this exponent in terms of fifths. So this would be t to the 10/5. Why? Because 10/5 reduces down to 2, times t to the minus 3/5. And then this will give me minus 1 plus, and I'll rewrite this as t to the 1/7 times t to the minus 1. So I did a lot in this step. First of all, I rewrote t squared as t to the 10/5. I just carried over this factor right here. Then I went ahead and distributed this minus to both terms in the parentheses here. So this becomes the term minus t over t, which reduces down to 1. And this becomes the term minus a minus t to the 1/7 over t. And I rewrote that t in the denominator as t to the minus 1 there. So I did quite a lot. Be very careful here, folks, where it is essential that when I simplified this fraction by dividing t into both terms in the numerator, it is essential that I put that parentheses there, or I somehow appropriately take care of this minus sign being distributed to each term. So continuing, here I can go ahead and combine those exponents by my properties of exponents. This becomes t to the positive 7/5 minus 1, and then we're getting real close here. I'll rewrite this t to the 1/7 one more time, and then I'll rewrite this as times t to the minus 7 over 7, so I can go ahead and get ready to combine those fractions. So this gives me t to the 7/5 minus 1, plus combining these would give me t to the minus 6/7. That's one way to leave the answer. It's sort of customary to put them in to put the constant term over to the left-hand side, so you don't have to do this, but I'll go ahead and rewrite it. This is t to the 7/5 plus t to the minus 6/7 minus 1. Now, folks, if you found this problem challenging, I am going to encourage you to go back and review these properties of exponents, rational exponents, and nth roots from earlier handouts, because this is definitely a much more difficult problem than we saw in those. I want to reiterate, let's just say one thing. Let's go ahead and give the answer one more time as y sub t is equal to t to the 7/5 plus t to the minus 6/7 minus 1. And I want to point out that because I was given a named function here, I referred to that named function when I wrote out the answer. If you just wrote out the t to the 7/5 plus t to the minus 6/5 minus 1, and you didn't have this y sub t equals or y equals or something to that effect, I would probably dock you a point, not a significant number of points, but just a point on a 7 or 8 point problem for failing to label this. So I do want you to, if I give you the name of a function, I want you to relabel it later on. So folks, this is a challenging enough problem that I'm going to ask you to practice it a couple more times here. So I'll let you try it in this problem. You'll notice that there is a hyperlinked solution to that. So you can try this. Notice this is very similar. I mean, it's different name for the function, different variable, but you should be able to sort of mimic your work in this problem with this one here. Okay? There are some slight differences. Then go ahead and try this one more time. And this hyperlink or this QR code will take you to a version of this problem in MyOpenMath, which I'll show you here. So if you click that hyperlink, you should see that it pulls up this MyOpenMath problem, an embedded question. This one's these questions are very similar but slightly different. You'll need to be careful with your fractional exponents, rewriting, distributing negatives, etc. You can try this as many times as you like. It will tell you if you've got the wrong structure, like if I just put, let's just say I put t to the 1/3 or 1/2, it tells me I've got a syntax error. That's because I'm forgetting an f of t. This is the incorrect answer here. Now at least it doesn't say there's a syntax error. And if I hit submit, it will check my answer. I can see the correct answer, and I can try a similar question. So what I'd like you to do here is I'd like you to repeat this problem until you get the correct answer. Copy down both the question and your work for the version that you get the correct answer, and you can do this as many times as you like. So first, we go ahead and use this problem here where you've got a completely worked out key for this example, and then you'll try something similar here. In the next video, we'll look at some other common types of problems that you'll encounter in your calculus course where you'll have to use these properties of exponents in a way that you may not be familiar with. So I'll see you there.